Hello, computational music theorists. Our topic for the coming week is going to be on intervals and equivalence and working with what equal and the same and so on mean. I am very much trying to treat everybody in this class and everybody I meet as equals. But that doesn't mean that I think that everybody is the same. In fact, that would be a very unequal way to treat people. So we can have this notion that equality does not mean the same thing, and that equal does not mean identical. This is something I hope we practice in our lives, but it's also very important in thinking about how we compare musical structures. I'm asking you over the weekend to read a very interesting chapter from Dmitri Tymochko's A Geometry of Music, in which he talks about 5 kinds of equivalence, a few more, but mostly about 5 kinds that he calls OPTIC: octave, permutation, transposition, inversion, and cardinality. These ways of thinking about equality of notes or melodies or chords or other musical structures, even whole pieces, is going to be very important when we want to find particular musical gestures or we want to identify particular things using a computer. I'm sitting at the piano because I'm going to demonstrate a few of the things that we might think mean that something is equal or something is the same, but maybe they're not identical. But first, I want to play something that doesn't work very well on the piano, so listen to these 2 pieces.
The way you wear your hat, the way you sip your tea, the memory of all that. No, they can't take that away from me. The way your smile just beams, the way you sing off key.
The way you wear your hat, the way you sip your tea, the memory of all that. No, they can't take that away from me. The way your smile just beams, the way you sing off key.
I asked you to listen to 2 pieces. Actually, I just played excerpts. But did I play 2 pieces? Or did I play 1 piece twice? Were those 2 pieces the same piece? Were they the same recording? I think we'll think that, well, they were the same piece, but different recordings, different performers, different styles, different interpretations, but there was something the same about them. So we can think of an equivalence class or a kind of equivalence between pieces. That doesn't necessarily mean that they are identical. Now let's turn to some musical structures that we can demonstrate at the piano. So I want to talk concretely about some ways that we might think about equivalence and what do we mean by equivalence when we're talking about notes or chords or melodies or pieces. And I want to think about some of the things that we might be doing. So, for instance, can we think of a context where notes as a group are the same regardless of the order that we talk about them? Let's start with just a C major chord, C, E, G. And if I say C3, E3, G3, and that's the chord. Or if I say that it's G3, E3, C3, it's still the same chord. or if I said that the chord is E3, C3, G3, it really doesn't matter. So this could be, when we're talking about chords, a place where there is a permutation equivalence. Doesn't matter what order they're in. On the other hand, if we're talking about a melody or something, some sort of a piece that has, then it matters if we go, sorry. Those don't seem to be equivalent in some context that we might think of as equivalence. So there could be a context where P, permutation equivalence, is active, and a context where it isn't. We can also think of cardinality, especially on the piano. It doesn't matter if I play C, E, G as a chord, or if I play C, C, E, G. I mean, you can't even tell. Maybe I can put 2 fingers on the C or something like that. But in a chordal context on the piano, we would normally say, well, that cardinality doesn't really matter in terms of the sound. If you're going to be notating it, then yeah, it matters. We also can think of octave equivalence, that all those notes are C. When we say something like all of these things are, we're saying that they're equivalent in some way. So we're saying that in this case, when I say all these notes are C, we're talking about an octave equivalence relationship. But I can't say that all of those notes are C3. Only that note is C3, C2, C4. If you were, an instrumental teacher and you ask somebody on an instrument like, flute or the clarinet or the violin to play a scale in 3 octaves, and they just play the same octave, you'd really say, no, I asked for 3 octaves. So we can think of a world where there isn't an octave equivalence. And we can put these 2 things together, that we can think C, E, G, C. We have a kind of world where we say, well, that's the same as C, E, G, in the sense of play the tonic triad in C major. It doesn't matter if I play. And those all fulfill this particular equivalence class. And there are other ones. One of the ones that Tomachko sort of assumes throughout and isn't even a part of his OPTIC, OPTIC world is spelling. So it doesn't matter, or C major is a little bit hard, but it doesn't matter if I think of a single note, play E flat, play D sharp. It's the same thing. So we can think of a spelling equivalence. Now, if you were to be in Theory 1 class and you're asked to write a C minor triad and you write C, D sharp, G, you're probably going to get marked wrong, because that's a context where there is not spelling equivalence. We can also think of a world where there's a transposition equivalence. So for instance, and we can say, oh, well, those are both the same piece. Those are both Mary Had a Little Lamb. So that there's a transposition equivalence that makes that piece still Mary Had a Little Lamb. And we definitely use that when we're talking about chord types. So we talk about that's a major triad, that's a major triad, that's a major triad, so that we can talk about a concept like major triad that takes into account that there's a transposition equivalence. probably the one that people like the least and think that it's not really a context that we want to be working with is the inversion context. And when we play something in a tonal context, like a C major triad, and then we invert it, so let's see, from E to G is a minor third, so we'll go from G, B flat is a minor third, and E to C is a major third, so B flat to D is a major third. So we can say in an inversion and transposition context that those, well, I guess it's not even a transposition context, that those two are equivalent. And that might go, whoa, what are we talking about? But there are some places in post-tonal theory where that's important, but we can even think about it even in the tonal, or in this case, a pre-tonal context. Here I'm going to play 4 pieces. One goes, well, I'll do the one we just played. Here's another piece. And here's another piece. Play that one more time so you get in your ears. And then we can have a piece like this. I played, in some sense, 4 different melodies or something, but maybe I only played 3 different pieces because we can recognize, oh, those last 2 are the same piece, but one is upside down from the other. This is actually a piece that was really famous in the 15th century called L'Homme Armé, or the Armed Man. And composers at that time liked to play around with it. They transposed it. They did diatonic transpositions so that you play in different modes. So instead of maybe you play something like, and it's a slightly different piece, but still the same piece. So you can think of a diatonic transposition equivalence, but they also definitely played with what I was showing, the inversion equivalence context. So that are in some ways the beginning of the same piece. We're going to be asking you in the problem set to see if you can come up with other contexts where we talk about, well, that's the same thing. Like, is this a C major triad? Good. Well, this is a fancy piano, so I'm going to change the temperament to mean tone. And now we go. Maybe over Zoom you can't hear the difference as much, but we can go to a slightly different one even. Or, and those are all the notes C, E, G. They're not exactly the same, but we think of them as the same. So we can think of a temperament context or a tuning context where we allow things to be equivalent. So I think this is the background that you need in order to go through the reading of Dmitry Chmachko on optics and equivalence. As usual, you're going to be implementing your code in Python using musical objects either that you create or that you have unlocked in Music 21. And when you're doing this, you think about what 2 objects are. What are 2 notes that Python defines as equal, or that I have defined in Music 21 defines as equal? What do we mean by that? And you'll see that each object in the computational language generally has only one built-in sort of equivalence set that defines what the equal operator or whatever it is means. And well, there's actually a second one, the is operator, that defines something else. What do we mean by these 2 objects are the same. The is the same is what I wanted to say. But, and what choice was made, and how could we have made a better choice, and who's going to hate me for the choice I made, and who would have hated me if I made another choice on defining equality in a note or an accord. Thanks for listening to this video, and now let's get started with reading what Dmitry Chwachko has to say on this subject.